Hello, ladies and gentlemen. Today we're going to be talking about analyzing function graphs. There's a couple different things that we can basically look at a function and say about them just by looking at their graphs. That's kind of what our goal is going to be for today. The first of these things that we're going to be talking about are the increasing and decreasing, okay? And basically you're going to see kind of this weird definition that might take a second to understand, but the main idea behind this is that if a function is increasing or decreasing, as you move along the x, the y is either going up or it's going down. I kind of call this a common sense principle because you can kind of look at something and say, oh yeah, that's increasing or that's decreasing, okay? But just to have that formal definition for us, a function is strictly increasing on an interval if when x1 is less than x2, then y1 is less than y2, and that's for all x's on that interval. Okay, basically what it means is that for every x value as you go, the y value that's associated with it will be less than the next y value that's there all the way across, okay? And then for decreasing, it's basically going to be the opposite, okay? Your y1 is going to be greater than your y2, meaning that the next value, the next y value is always going to be less as we move across the x's. Now, for a function to be constant, then y1 will be equal to y2. Basically, that all your y values are the same on that interval, no matter what x values you're looking at, okay? And again, these definitions, when we look at them, are a little confusing. They're kind of a weird algebra speak, okay? But, as we're going to see in a second, when we're actually looking at the graph, they're pretty easy to see if something's increasing or decreasing, and that's going to be the main thing we have to do. So, for example, here is a graph of a function that we're going to determine where it is increasing, where it is decreasing, and where it is constant. All right, so let's look at how we're going to do that. So we're going to start by listing all the things for increasing, okay? So everywhere that it's increasing, we'll go ahead and list that first. All right, so for something that's increasing, basically you're looking for something where the graph is going up all the way across that interval, okay? So for example, this interval right here, big example of where we are increasing. If I look from left to right on my x values, my y values are going up over that entire thing, okay? No matter where I look, everything keeps going up the whole way across. So that would be one example of a place where this function is increasing. So if I look here, that's 1, 2, 3, 4, 5. It looks like from -5 to -3, my function is increasing. Now, if I want to keep looking for places where I'm increasing, it looks like right here I'm increasing as well. Now, it's not a constant rate of increase, right, because it's kind of curving as it goes, but it's definitely going up the whole way across there. So we'll say union, and then also from -1 to 1, we are increasing. And then I also see here from 4 to 5, it looks like I'm also increasing as well. So I'll say, hey, from 4 to 5, I am also increasing. You'll notice that I'm not including those ending numbers in my intervals because we can't be increasing at a specific point. In fact, based off our definition, it has to be a range. So I can't say, oh, at -5 I'm increasing, because at that specific point, I can't compare it to anything else to see if I'm increasing or decreasing. So automatically, those things are not included when I'm listing my intervals. All right, the next ones we're going to go ahead and list out will be the decreasing. We'll put that down here. And again, very similar to what I was looking for the increasing. But in this case, I'm looking for those y values to be going down as opposed to up. And lucky for me, I can kind of see there's a couple places this is going on. So first off, from here at, let's see, this is 1, 2, 3, 4, 5. So at -5 and beyond here, looks like this would be decreasing, right? Thinking of it from left to right. And this is going on forever, right? I have an arrow end on there. So my decreasing here will be from -infinity to -5. The other place I see decreasing is here. It looks like from 1 to 4, I'm decreasing as well. So I would say union with 1 to 4. The last one I'm going to list out is my constant. For the constant, I am looking for where my function is neither increasing or decreasing. It's just staying the same the whole way across. And we have a couple intervals for this function where that is occurring as well. It looks like from -3 to -1, my function is constant. And then also it looks like we are constant if I go from 5 out to infinity. One thing when you're doing this analysis and you're saying, oh, here's where my function is increasing, decreasing, or constant, is that you should be able to look at all of those intervals that you just listed, and it should equal the domain of your function. You should basically be including everything there, because your function can only do these 3 things. It either goes up, it goes down, or it stays the same. So I can kind of follow along and bump along and make sure I've included everything that I'm looking for there. So from -50 to -5, I'm decreasing, and then from -5 to -3, I'm increasing, and then -3 to -1, I'm constant, and then -1 to 1, I'm increasing, 1 to 4 decreasing, 4 to 5 increasing, 5 to infinity constant. All the values of my domain are being included there except for those the points in between, okay? But besides that, everything is included. I can go right across and kind of follow along to see all that my function is doing. Okay, the next thing we're going to talk about is called a relative maximum or a minimum. Okay, and basically what this is we're looking for a point that is the highest or the lowest based off what's around it. So basically the things around it are all smaller than it. Okay, so f of a is a relative maximum if there exists an interval x1 to x2 such that a is greater than y1 and a is greater than y2. Sorry, this actually should be f of a is greater than y1 and f of a is greater than y2. Basically, the y value needs to be greater than all the y values around it. Now, this does not mean these are the absolute maximum and minimum. Those are the highest and lowest numbers, period, okay? A relative maximum minimum just means that it's higher than all the things around it. It kind of basically, if you think about it, is like a turning point. Where does my function turn from going up to down or from down to up? Where is it turning? And those are going to create maximums and minimums, okay? Same exact definition for minimum, except that f of a has to be less than y1 and less than y2. And what this definition is basically telling us is that for all of the x values that surround this, okay, for all of them, they need to be, the y values that correlate with them need to either all be higher than your maximum, your minimum, or they need to all be lower than your maximum. Okay, and so here all my values out for that minimum are going to be lower than the y1 and the y2. Again, the definition might seem kind of confusing, but in practice, it's really not that hard to identify. So here we have that exact same function again, and we're going to identify what points are the maximum and the minimum. And when I'm talking about the points, we're really only concerned with the x values that are providing you where that maximum or minimum is located. If I want to know the value of the maximum or minimum, then I care about the y. But we're basically looking for where are they located. You'll even notice this doesn't have dashes on the y. We're not concerned about that. We're concerned about where are these maximums and minimums located. And when I go ahead and I look at this, first of all, I see a relative minimum right here. Now, Mr. Guy, that's not the lowest point in your function. You have lower point over here. That's okay. It is just lower than everything that's around it, right? I can make an interval here where all of the y values are greater than this point. So let's see. This is at 1, 2, 3, 4, 5. So x equals -5 would be a minimum. I'm going to write min to represent that. If I keep going, well, would this be a maximum or minimum? That one would not be, because I cannot create an interval where everything is higher or lower than it, right? Anything to the right of this point is going to be the same as that point, meaning it doesn't qualify as a maximum or a minimum. This point would be the next one that I have, and that one would be a maximum. So x equals 1 would be a maximum. Okay, and why is it a maximum? Because all of the points around it are lower than it. I can create an interval where everything around it is lower. It's all giving me lower output, so that is a maximum. Last but not least, we have this one right here. This is also a minimum, so that's at x equals 4. And again, I can create an interval where everything around it is less than it. All right, so this one has 3 maximums and minimums. Okay, it has 2 minimums and 1 maximum. We also could then go ahead and state what is the absolute maximum minimum. That would be a definition of, I'm sorry, I didn't mean to click that. That would be a definition of what is actually the highest or lowest point on our function. And what's interesting about this function is it actually does not have an absolute maximum, okay? This function keeps going on forever up, so we can't identify an x value where it's at its maximum because it keeps going out to infinity and we can't do that. However, it does have an absolute minimum. This point at x equals 4 would be the absolute minimum. Okay, you could write in parentheses here absolute. I'll write ABS for absolute. Okay, but that one is the absolute minimum because it is the lowest point of our function. This function does not keep going down infinitely. It doesn't have anything lower than that, so that would be that absolute minimum. It's lower than everything else that's around it. All right? Please stay tuned and go ahead and watch part 2 where you can learn about the symmetry of these functions.